right, well, let's go over the review because we got a test coming up really soon. So within the next day. All right. So this review, you should have it all done. I already sent it to me. First question. All right. And the way in which to do these is make sure you have the balanced equation written out. So I'm going to write out the balanced equation for number one, which happens to be C2H4 plus 3 O2s. That forms 2 CO2s plus 2 H2Os. All right, and then it says, how many moles of C2H4? So we got X moles of this guy. When we needed to react with 76.2 moles of O2. So we got 76.2 moles of this guy. All right. So now again, the way in which to decide this, and you got that cheat sheet, which is all these ratios over here. Look at the one that's got a number. That's this one, 76.2. Look at the units, moles. All right. I know moles makes it hard, but what you got to do is go, okay, well, that can be the top one, it can be this one, it can be that one, it can be that one. Right? But then what are we trying to find out? Well, we're trying to find moles of another thing. Oh, that's the first one, moles to moles. Right? According to the cheat sheet, if you look at it, it says we use the ratio from the balanced equation. So that means we're going to use that one of this combines with 3 of that. So 1 mole of C2H4 will combine with 3 moles of O2. Well, then we go, well, we don't have 3 moles of the O2, we have 76.2 moles of O2. And we want to find X moles of C2H4. So the red, that's the question part at the top, the black, that's the balanced equation. All right. Now we just got to cross multiply 3 times X equals 1 times 76.2. Divide by 3, divide by 3, and X will equal, the right answer is 25.4. And that's moles of C2H4 is the answer. All right. So that's what you should have for the first one. All right, so now we go on to the second one. Now, the second one, we have a new recipe, which means we have a different balanced equation that we have to use. So this one, the balanced equation is 4NH3 plus 6L forms 5N2 plus 6 H2Os. There's my balanced equation. And it says, the question says, how many grams of water? So we want to know X grams of this guy, way over there. Will be produced from 123 grams of NH3. So 123 grams of this guy. Now we don't have to worry about this one or that one because it didn't ask anything about them. All right. So this one, start with the one that's got a number. The units are grams. So the options we got this one and we got that one. Those are the only 2 that have grams. What are we trying to find out? Grams. Oh, okay, that narrows it down. That means we're looking at this one where it's grams to grams. And we need to find out the molar mass of each of the things that are in black. So we got to go 1 times the mass of nitrogen is 14 from the periodic table, plus 3 hydrogens times his mass is 1, and all of that times 4 that's out in front. So if you multiply that out, you'll get 68 grams for that guy. Then we go to the water one. Well, it's 2 hydrogens times his mass is 1. Plus 1 oxygen times his mass is 16. All of that times 6. If you multiply that out, you get 108. Now, according to the cheat sheet, I got to use those 2 and set up a ratio. So I have 68 grams of NH3. We'll make 108 grams of H2O. Then I go to the other side and go, well, I don't have 68 grams. I got 123 grams of NH3. And we're trying to find out X grams of H2O. All right, now cross multiply 68 times X equals 108 times 123. Now you get X by itself, so divide both sides by 68. That makes X equal to 195 grams of H2O is what we're trying to find out. So there's my final answer. All right, and that concludes number 2. So now we're going to number 3. Number 3, oh, we're changing the recipe again, so I gotta erase my balanced equation again. And we'll erase this. Alright, so this time our recipe is 2Na2O2 plus 2H2O forms O2 plus 4 NaOHs. Here's my recipe, the balanced equation. Now we go to the problem, and it says how many grams of Na2O2? So X grams of this guy. That's what we're trying to find out. Is needed to react with water, so it's reacting with water, a whole ocean of water, because it doesn't tell me how much, just saying we got lots of it, to produce 75 grams of O2. So we're going to produce 75.0 grams of this guy. Alright, so we start with the one that's got a number. There's the number. Look at the units, which is grams. So according to the cheat sheet, we can use the blue one or the green one right here, one of those two. Then we go to what do they want to find out? They want to find out grams of this guy. Oh, so it's grams to grams, so it's this guy again. So according to the cheat sheet, I need to do a molar mass of each substance. So I need 2 times the mass of sodium, which is 23, plus 2 times oxygen, which is 16. And all of that times the big 2 out in front. If you do that, you get 156 grams for that one. Then we go over the O2, which is 2 oxygens times 16. All of that times the big number out in front. There is no big number out in front. Remember, in chemistry, there's no number, it's a 1. Alright, so this is 32 grams. Now we set up our ratio of those two. So I got 156 grams of Na2O2 will make 32 grams of O2. Then I go to the other side and go, well, let's see, we want to find X grams of Na2O2, that's this one, and we're going to make 75.0 grams of O2. Alright, cross multiply and solve this. So 32 times X equals 156 times 75.0. Gotta get X by itself, divide both sides by 32. And X equals 366. So 366 grams of Na2O2 will make 32 grams of oxygen. We'll make 75 grams of oxygen. Alright, that concludes number 3. Okay, so now we'll move on to number 4. Alright, number 4, so we got a new recipe, so we got to change this again. Alright, so the new recipe is 4P plus 5 O2s forms 2 P2O5s. Alright, so now we go to the question. The question says, how many grams of P2O5? So we want to know X grams of this guy. If we get 4.3 moles of O2, so we have 4.3 moles of O2. Alright, okay, so we're going to start with the one that's got a number, which is moles. Alright, and we're trying to go to X grams of this guy. So moles, remember moles, we can do the first one, this one, or this one. Alright, we can't do the grams because it's not grams. And we're trying to get to grams over here. Oh, well, hey, this looks like we could use this one, right? Because that's moles and grams. Oh, but wait a minute. Remember, all this does, this changes this moles into grams of this guy. Right? That's all it does. So what we have to do, okay, is making sure where my answers were on this so I get them worked out right. Alright. So let's go moles of this to moles of that. That'll get me over to there. So that means we're going to do the red one right here. So we're going to go 5 moles of O2 will make 2 moles of P2O5. Then we go, well, I don't have 5 moles of O2, I got 4.3 moles of O2. We're going to find X moles of P2O5. So cross multiply, 5 times X equals 2 times 4.3. Divide by 5, divide by 5. And X is going to equal some answer. Oh, 1.72 moles of P2O5. I want to make sure that's right. I don't want to lead you guys wrong. So I'm going to take 2 times 4.3. And I'm going to divide that by 5. 1.72. Okay. So now we know that this number up here is 1.72 moles. Okay. So now we know that that's moles. Now can I change moles of this into grams of this, the same substance? Yep, that would be the green one down here. And the green one says I got to know the molar mass of this stuff. So I got to do the molar mass of that. So I have 2 phosphoruses times his mass. So I look it up, I think it's 31. Yep, 31 plus 5 oxygens, which is 16. All that times 2. So this is 62, and that's 80. Add those two guys together, that's 142. All that times 2. So that's like 284 grams. All right, so from there we're going to go 284 grams of P2O5 is 2 moles of P2O5. I'm going to go to the other side and go, well, I don't have 2 moles, I have 1.72 moles of P2O5. We want to find X grams of P2O5. Move that over, I don't think I'm on, there we go, now we're on the screen. Cross multiply 2 times X equals 284 times 1.72. Divide by 2, divide by 2. X is the equal. So let me do this guy. Clear. We get 284 times 1.72 and divided by 2 is 244. So X is 244, and that was grams of P2O5. And that was what they were asking for, because they were looking for grams of this. And there goes my light, so hold on. All right. And where are we at in time? Okay. So, on to the next one. What's the limiting reagent? Ooh, okay. So, we're starting with a different chemical reaction. So, we got to change the recipe on this one. All right, so the recipe is carbon monoxide plus 2H2 forms CH3OH. All right, and then according to the question, it says we got 1.9 moles of CO. Got 1.9 moles of that. And we have 4.1 moles of H2. All right, so we got to choose one of them, make it X. Does it matter? No, it doesn't really. So, let's see. Let's make this guy X. All right, so we're going to make the H2X. So that means, again, we're going to ignore the 4.1, and we're going to go with 1.9. And this is moles to moles, so it's the first process. So we're going to go 1 mole of CO. We'll make 2, or it combines with 2 moles of H2. All right. Well, then we got really 1.9 moles of CO over my green one, which is X moles of H2. So cross multiply. 1 times X equals 2 times 1.9. Divide by 1, divide by 1. So X ends up equaling 3.8. That's moles of H2. So according to this guy, is that if I use all 1.9 moles of this, I need 3.8 moles of H2. Do I have that? Yeah, I do, and I got a whole bunch extra, don't I? So this guy right there, that's my limiting reagent. All right. All right, based on time, we're going to stop. We'll go on to part number 2. See you in a minute.